Today, let us continue yesterday's chapter. Before that, today is September 5, Teachers' Day. This is first time we are celebrating, not actually celebrating, uh, Teachers' Day. We teachers, lecturers, miss you, all you guys. Okay. Today let us start next concept. What? See, in last class we have studied what relation between focal length f and radius of curvature r in case of concave. These things in today's class, what we are going to study, you have already studied in your school classes. What rules for drawing image formed by spherical mirrors? Let us take a good example, only example of concave mirror. What we have to study? Rays to be considered while drawing image of an object. At the end, optics is all about, it's a game between what? Image and object. Remember, there is no concept called single ray. It's always in beam, group of rays. Anyways, to construct an image, we have to consider some of the rays. Like, see, first ray we are supposed to consider, okay? Let me take example of concave mirror only. Concave mirror example we will tell, okay? Pole and principal axis. We have to consider a ray of light along principal axis also. Let us consider a ray is moving along this principal axis, is incident along principal axis. What we observe? After reflection, it will retrace the same path. As the ray will do reflection on Puna Ade. Please remember what we have to do. We have to consider this ray also. Next, if you consider a ray of light from an object which is kept at infinity, a ray after striking a concave mirror must pass through focus, principal focus. This is first ray. Let me repeat. This is the first ray we are supposed to consider while drawing image of an object. Which ray? A ray from an object after incident on this concave mirror reflect and will pass to the what? Principal focus of the concave mirror. Same can be extended to what? Convex mirror also. Anyway, let us take example of concave mirror only. Okay, this is first ray. See here. Second ray to be considered. Once again, let me draw concave mirror, principal axis, and the plane. Now imagine a ray is allowed to pass through focus of a mirror. ಅನ್ಕೊಳ್ಳಿ, ನೀವೇನು ಮಾಡ್ತಿದ್ದೀರಿ? ಯಾವುದೋ ಒಂದು ರೇಗೆ ಅಲೋ ಮಾಡ್ತಾ ಇದ್ದೀರಿ, ಯಾವುದೋ ಒಂದು ರೇ ಪಾಸ್ ಆಗುತ್ತೆ ಥ್ರೂ ದಿಸ್ ಫೋಕಸ್, ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್. ದೆನ್ the reflected ray will proceed parallel to the principal axis. The reflected ray will move parallel to the principal axis. This is reverse condition. ಇದರದ್ದು reverse condition. A parallel beam of light, of course, paraxial rays we have to consider. A parallel beam of light when allowed to fall on certain point on the principal axis, it will reflect and pass through the principal focus. Similarly, if we allow a ray of light, a beam of light to fall on F, after reflection, it will move, proceed parallel to principal axis. Third ray. Third principal light. Once again, let us consider principal axis and the pole. Principal axis and pole. Imagine a beam of light, a ray of light is allowed to fall exactly at peak. Pole ಮೇಲೆ below not. When it is incident on pole, it will reflect in this fashion. This is incident ray, this is reflected ray. When ray of light from an object is allowed to fall on pole, it will follow. Okay, everywhere it will follow what? Rules of reflection. In every case, rules of reflection are followed. Here what? This is the incident angle, this is incident angle, this is reflected angle. This is theta, this is theta. Both are equal. It is very useful in deriving next derivation, which is so-called mirror equation, where we are supposed to consider this ray. Let me repeat. In next derivation, we have to consider this ray. So that this incident angle is equal to reflected angle. This is third ray we are supposed to consider. This is third ray we are supposed to consider. Let me draw fourth ray. Okay? Somewhere here I will write. Right? Okay. This is mirror. Okay? Pole. Let me consider an object placed in front of this mirror. Then, if ray of light or beam of light, if it is allowed to pass through C, what is C? C is center of curvature. If ray of light is moving through C, better. If ray of light is moving through C, then suppose it's moving along normal. It's moving along the normal. We know it's curved surface. Correct? We draw normal in the direction of radius of curvature. This is normal. Hence, it will retrace its path in the same direction. It will retrace its path from the same direction. Reflection remember, everywhere you have to consider what? You have to consider a ray along principal axis also. Okay, right? Principal axis also. These are four major rays to be considered while constructing an image. Remember, to construct an image, we require minimum 2 rays. ಎಷ್ಟು rays ಬೇಕು? 2 rays ಬೇಕು. We can use 3 rays also. Go hard and fast. In next derivation, we use 3 rays to simplify, to get some similar angles, triangles. We will discuss there. But remember, these are 4 rays to be considered while constructing an image of an object. Among these 4, minimum 2 required. ಎರಡು ರೇಖೆಗಳು ಬೇಕೇ ಬೇಕು. We need any 2 rays to construct image. Maybe 3 also. 3 ಆಗಬಹುದು, 2 ಆಗಬಹುದು. ಯಾವುದು? First ray, which is parallel to principal axis, after reflection passing through focus. Second ray, if This ray is moving through, passing through focus. After reflection, it will proceed parallel to the principal axis. If a ray of light is incident on core, it will reflect like this, obeying the laws of reflection. ಯಾವುದೇ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಬಿದ್ದರೂ laws of reflection follow ಆಗುತ್ತೆ. And fourth one is, if ray of light is allowed to pass through C, or if ray of light is moving through C, then it will replace this path. Minimum 2 rays you have to consider while drawing an image. Okay, this is one thing. Hope you understand. Next, thing is, once again from our high school section, nature of what? Nature of image formed in concave mirror, let us say, and later let's go to what? Convex mirror also. ಒಂದು ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅಲ್ಲಿ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆದಾಗ ಅದರ ನೇಚರ್ ಏನಿರುತ್ತದೆ, ನಾವು ಯಾವ ಯಾವ ಡಿಫರೆಂಟ್ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನು ಇಟ್ಟು ಇಮೇಜ್ ನೇಚರ್ ನ ಸ್ಟಡಿ ಮಾಡ್ತೇವೆ. What we do? We put object in different positions, and we just try to know what nature of image form. Okay, let me write. Once again, position of an object and image form. Position of an object and image form. Here we are supposed to use those 4 rays. ಯಾವುದಾದ್ರು rays ಅನ್ನು ಯೂಸ್ ಮಾಡಿ ಆ 4ರಲ್ಲಿ 2 rays ಅನ್ನು ಯೂಸ್ ಮಾಡಿ. ಫಸ್ಟ್ ಹೀಗೆ ಒಂದು ಡಯಾಗ್ರಾಮ್ ತೋರಿಸ್ತೇನೆ ನೋಡಿ. Let us consider a concave mirror only better. Then let's go to convex mirror. Convex mirror ಯಾಕೆ ಅಷ್ಟು ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಡ್ತಾ ಇಲ್ಲ ನಾವು? Let this be principal axis, very big one, principal axis. This is 4. Okay. Now, let's go to it. Already helpful. You know this already. But the notes are correct. Okay. Okay. Somewhat written, right? Okay. No problem. When object is placed far away, from the concave mirror, I am taking concave mirror, a ray of light after reflection, we know this, will meet at a point on principal axis. This point is called principal focus. This position is usually called at infinity, is called as at infinity, quite long. At infinity. When the object is placed at infinity, please observe carefully. When the object is placed at infinity, after reflection, image is formed at F. Very much diminished term used. Diminished. ತುಂಬಾ ಚಿಕ್ಕದಾಗಿರ್ತದೆ ಗಾತ್ರದಲ್ಲಿ, ಪಾಯಿಂಟ್ ಸೈಜ್ में ತುಂಬಾ ಚಿಕ್ಕದಾಗಿರ್ತದೆ ಗಾತ್ರದಲ್ಲಿ. Diminished. Inverted. Okay, let this is the object. Probably for chemistry they have used. ಸೂರ್ಯ ಈಚೆ ಕಾಣ್ತಾ ಇದ್ರೆ ಅದು ಆಬ್ಜೆಕ್ಟ್ ಇಮೇಜ್ ಹೀಗೆ ಕಾಣ್ತಾ ಇದೆ, ತಲೆ ಕೆಳಗಾಗಿ. ಇನ್ವರ್ಟೆಡ್, ಇನ್ವರ್ಟೆಡ್ ಅಂದ್ರೆ ತಲೆ ಕೆಳಗು, ತಲೆ ಕೆಳಗಾಗಿರುತ್ತೆ. ಡಿಮಿನಿಶ್ ತುಂಬಾ ಚಿಕ್ಕದಾಗಿರುತ್ತೆ ಆಸ್ ಕಂಪೇರ್ಡ್ ಟು ಒರಿಜಿನಲ್ ಆಬ್ಜೆಕ್ಟ್ ಸೈಜ್. And we say this image is real. You know this term real. What do you mean by real image? ಯಾವ ಇಮೇಜ್ ಅನ್ನ ನಾವು ಪರದೆಯ ಮೇಲೆ ಹಿಡಿಯೋದಕ್ಕೆ ಸಾಧ್ಯ ಇದೆಯೋ, ಸ್ಕ್ರೀನ್ ಮೇಲೆ ಹಿಡಿಯೋದಕ್ಕೆ ಸಾಧ್ಯ ಇದೆಯೋ, ಅವಕ್ಕೆಲ್ಲ ರಿಯಲ್ ಇಮೇಜಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. In case of vacuum mirror, it is possible to what? Catch image of an object on screen. We can catch literally what? Image on screen. But image, nature of image is it is inverted. ಏನಾಗಿರುತ್ತೆ ಅದು ತಲೆ ಕೆಳಗಾಗಿರುತ್ತದೆ. While solving problems, remember these things usually asked. The right nature of image form. ಏನ್ ಹೇಳ್ತಾರೆ ಅವರು? ಇಮೇಜ್ ಹೇಗಾಗುತ್ತೆ ಅದರ ನೇಚರ್ ಅನ್ನ ಬರೆಯಬೇಕು. Then you have to write it as whether diminished, inverted, real. In a concave mirror, in most of the positions, real inverted image is formed. ಏನಾಗುತ್ತೆ? ರಿಯಲ್ ಫಾರ್ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಇನ್ವರ್ಟೆಡ್ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಇನ್ವರ್ಟೆಡ್ ಇಮೇಜಸ್ ಎಲ್ಲ ರಿಯಲ್ ಆಗಿರುತ್ತೆ. ನೆನಪಿಟ್ಕೊಳ್ಬೋದಾ? ಪ್ಲೇನ್ ಮಿರರ್ ಏನಾಗಿರ್ತದೆ? ಥಿಂಕ್ ಮಾಡಿ. ನಿಮ್ಮ ಮನೆ ಒಂದು ಕನ್ನಡಿ, ನಿಮ್ಮ ಮನೆಯಲ್ಲಿ ಒಂದು ಕನ್ನಡಿ ಇರುತ್ತಲ್ವಾ, ಪ್ಲೇನ್ ಮಿರರ್ ದರ್ಪಣ ಇರುತ್ತಲ್ವಾ, ಅದನ್ನು ನಿಂತ್ಕೊಂಡಾಗ ನಿಮ್ಮ ಇಮೇಜ್ is real or virtual. The next term is virtual. ಮಿಥ್ಯ ಪ್ರತಿಬಿಂಬ, real image, satya pratibimba, incorrect. Okay, here when object is placed at infinity, the nature of image formed is it is diminished, very small, inverted, tale kelagu, and it's real. Yake real? We can catch it on what? Screen. Next position. Let me draw some idea. Let this point be C. This point is C. This second position, this is first position we have studied. This is second position. This second position is called beyond C. Beyond C or away from C. This is point. This is infinity. This is beyond C. When object is placed beyond C, image, let me draw those images with the ray only. Okay, here for knowledge sake, the nature of image is inverted, and it's real, it's a real one. And less than object size. Size of the image is less. Size of the image is less. It is less than object. Diminished. Actually diminished. Here its value is diminished. Here actual size is less than what? Less than object size. What next? This is second position. Hope you understand. When you place object exactly at C, ನೀವು ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಸಿ ಅಲ್ಲಿ ಟ್ರೈನ್ ಆಗುತ್ತೆ. ರಿಮೆಂಬರ್ ಇಮೇಜ್ ಇಸ್ ಫಾರ್ಮ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ at C. ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್ ಏನಾಗುತ್ತೆ? ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಸಿ ಅಲ್ಲೇ. When object is C, image is formed at C only. What is the nature? Once again it is inverted, hence here it is inverted, real, same size as that of object. Object the size is same. It is same size as of object. Object the size is same. There is no difference in size of object as well as image. Next. Fourth position will be, imagine now your object is placed between C and F. C and F. When object is placed between C and F, then your image will shift beyond C. Let me write this position of first image. This is position of second image. This is position of third image. This one is fourth image. Position of fourth image. Position of fourth image. You can note it down. Position of fourth image. Once again, inverted, real, but enlarged than original object. Object size ಗಿಂತ ದೊಡ್ಡದಾಗಿರುತ್ತದೆ. Object size ಗಿಂತ ಏನಾಗಿರುತ್ತದೆ? ದೊಡ್ಡದಾಗಿರುತ್ತದೆ. It is bigger than object size. Fourth position. Let me take fifth position also. When object is placed exactly at position number 5. When object is placed exactly at F, then your image will be at infinity. Image ಅಲ್ಲಿ ಹೋಗ್ಬಿಡುತ್ತೆ ಇನ್ಫಿನಿಟಿ ಹೋಗ್ಬಿಡುತ್ತೆ. ಇನ್ಫಿನಿಟಿ ಇಟ್ಟಾಗ ಎಫ್ ಗೆ ಬಂದ್ಬಿಡ್ತದೆ, ಪಾಯಿಂಟ್ ಸೈಜ್ ಆಗಿರ್ತದೆ. ಎಫ್ ಗೆ ಇಟ್ಟಾಗ ಎಲ್ಲಿ ಹೋಗ್ಬಿಡ್ತದೆ? ಇನ್ಫಿನಿಟಿ ಹೋಗ್ಬಿಡ್ತದೆ. This is once again inverted, real, very much enlarged. ಇನ್ನೂ ಸಹ ಏನಾಗಿರ್ತದೆ? This is inverted, real, and very much enlarged. Very much enlarged. In these 5 cases, you get only real inverted images. Only thing is size of the image varies. Size of the image varies. Remember, size of the object remains same. Object size change agata. Whatever change is in case of what image only. Image only. Forgetting. There is some last position. When object is placed between F and P, say something. Say position number 6. This is 6. When object is placed between F and P, then no real image is produced. Virtual, erect, inverted, ulta, erect, erect, image is formed inside the mirror only. Mirror ಒಳಗಡೆನೆ ಉಲ್ಟಾ ಆಗೋದಿಲ್ಲ, straight, erect, enlarged images. Here, image, nature of image is, it is virtual. In 6th case, image produced is virtual image is produced. What? Here, virtual image is produced. Virtual. It's not real. Erect, big one. It's not erect, and virtual image is produced. Virtual image is produced. Remember, this property is used by dentists. Doctor dentist to check. They use some mirror, correct? They place inside your mouth and they just check. To check toothache. Sometimes they use some tooth filling, somewhat called root canal or toothache. Such things to check your tooth. Take what they do? Doctors, dentists use this. Or This kind of mirror is used in saloons, beauty parlors, where you can see your enlarged face. Enlarged face. It's used by dentist actually. Dentist to check the toothache, all those things. Dentist. Check root canal, all those things. You know that. And used in beauty parlors or saloon shops. Saving saloon shops, beauty parlors. Why? Virtual, erect images formed inside the lens only. Inside the mirror only. These are some different positions you are supposed to remember. If you remember this, it's very easy to what? Remember next derivation, figure of next derivation, and while solving problems also. It's very useful. One more thing, it is very useful in doing experiments. As I told earlier, we have 5 to 6 experiments, optic experiment. If you clear picture of this position image form, there is no confusion while taking reading all these things. You lab and practical ಮಾಡಬೇಕಾಗುತ್ತಲ್ವಾ ಮಾಡುವಾಗ ಅಲ್ಲಿ ನಿಮ್ಮ focal length of concave mirror ಅನ್ನೋದು experiment ಇದೆ. Focal length of convex lens ಅಂತ experiment ಇದೆ. ಅಲ್ಲಿ ನಾವು ಏನು ಮಾಡ್ತೇವೆ? We use what? We used to measure what? Object distance and image distance. ಮಕ್ಕಳು ಎಂತ ಮಾಡ್ತಾರೆ? ಅವರಿಗೆ ಇಮೇಜ್ ಎಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ಎಲ್ಲಿದ್ರೆ ಇಮೇಜ್ ಯಾವ ಡಿಸ್ಟೆನ್ಸ್ ಬರ್ತದೆ ಅದು ಗೊತ್ತೇ ಆಗೋದಿಲ್ಲ. Just they do some try and error method. ಅಲ್ಲಿ ಬಂತ ಏನು ಬಂತ just struggle ಮಾಡಿ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರೆ. ಈ ಐಡಿಯಾ ಇದ್ರೆ ಇಟ್ಸ್ ಬೆಟರ್. ನಾ ಎಲ್ಲಿ ಇದ್ದೇನೆ, ನನ್ನ ಪೊಸಿಷನ್ ಎಲ್ಲಿದೆ, ಸೊ ಪ್ರಾಪರ್ ಪೊಸಿಷನ್ ಆಫ್ ಇಮೇಜ್ ಎಲ್ಲಿ ಇರಬೇಕು, ವಿ ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವೆರಿ ಎಫಿಷಿಯಂಟ್. ಓಕೆ, ನಾ ಆನ್ಸರ್. Okay, let me show some image formation using this ray concept, using this ray. Let us consider an object at infinity. When object is at infinity, then we know image, a small image is formed, okay, at f. Image is formed at f. This is f. Imagine your object is placed beyond c. This is somewhere c. Okay, let me take somewhere here c. You place your object here beyond c. Here we consider 2 rays. Correct? Here also we have to consider any 2 rays. A ray, usual ray, which is inside on some point on the concave mirror and passing through what? Passing through principal focus. Next ray we can take this ray. See here, this ray is second ray. A picture this is second ray. Okay, this point of intersection where two rays meet, here we get what? Position of image. This is the position of image. We know when object is placed beyond C, image formed is between C and F. Size of the image is small, and it's real and inverted. Real inverted image is formed. Now, when object is placed at C, say it another. When object is placed at C, say this is C. Then one usual way, you have to consider any two rays passing through F. This is F. One more ray which incident at point P. This is P pole, and will pass through this. We get what? We get image here, which is exactly equal to size of object inverted real. I hope you understand. This is ray number 1, ray number 2, ray number 1, ray number 2. Sorry, this is ray number 2. This is ray number 1, ray number 2. This way, we have to consider any two rays to construct what image. You can construct like this also. See, I will explain this. Instead of this ray, see somewhere see, first ray, F. We can consider this ray also. A ray starting from object, passing through C, incident on some point on mirror, and get reflected. See, once again we get intersection of two lines. This is a question. Here, the second ray is different as compared to earlier. Correct? Now I have taken second ray through C. We can construct once again object. I mean image, sorry. Once again image. Like you have to consider any two rays. Say. If we consider object at F, see somewhere here let me consider F. Let us see object. Okay, F, first ray. After reflection, will pass through F. And a ray from this point, imagine just incident at this point, and it will get reflected, it will pass in this fashion. So, image is formed somewhere here at infinity. You see? Now I have considered these two rays, ray 1 and ray 2. These two rays I have considered. A ray from this object incident somewhere here on concave mirror, and it is what? Reflected back. Say through C. Through C. Through C. You know, whenever the rays are pass through C, it will reflect back. It will reflect back. Correct? Okay. Answer. Hope you understand. This is at infinity. Object is at F. What happens if object is placed between P and F? Okay. Let me consider pole, principal axis, A passing through the principal axis. It is better to practice this ray also. Usually for it, it is better to practice this ray also. Please remember. Now, this is C. Okay, somewhere here I will write it. C. This is F. Imagine Object is placed somewhere here. Somewhere here means between F and P. Principal focus and pole. Then what? Ray will start from this object and this will pass through F. The ray will start from this point. It will pass through F. This ray. Let me consider another ray which start from this object, meet the mirror at point M. Say this some Q, whatever it may be. Okay, and it will replace its path. Now I have considered two rays, one through F, one through C. You can consider any two rays, one through F, one through C, one through pole, whatever it may be. Here, what? If you replace this reflected ray and extend this principal axis, what we have? See. Replace retrace that ಇದನ್ನು ಹಿಂದೆ ಡ್ರಾ ಮಾಡಿ somewhere here it's not very much scale ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ತಿರ್ಬೋದು ತುಂಬಾ ಸ್ಕೇಲ್ ಇಲ್ಲ it's just rough drawing if you retrace it back if you draw it back they will meet somewhere here. They will meet somewhere here. This is the image. Sorry, this is the image formed due to object which is kept between F and P. Definitely. I hope you understood the things. Okay? Clear? Things are clear? Okay. Now, what about case of convex mirror? Convex mirror ಏನಾಗುತ್ತೆ? Let me draw a convex mirror. This is convex mirror, correct? After a long time, we know this convex mirror. Okay. Principal axis. A ray traveling to principal axis will reflect back without any deviation. This is pole. And imagine an object is placed somewhere here. Correct? Once. Let me take first ray like this. This mirror is convex mirror or it's a divergent mirror. Divergent mirror. Hence, ray will diverge. ಹೀಗೆ ಹೋಗುತ್ತೆ ಉಲ್ಟಾ ಡ್ರಾ ಮಾಡಿದ್ದೇನೆ ಬಟ್ ಏನಾಗುತ್ತೆ ಹೀಗೆ ಹೋಗಿ see the direction of it. And let me consider second ray. This is first ray. ಸ್ವಲ್ಪ ಸ್ಲೋ ಹೇಳ್ತಾ ಇದ್ದೇನೆ ಅರ್ಥ ಆಗಲಿ ಅನ್ನೋ ದೃಷ್ಟಿಯಿಂದ ಒಂದ್ಸಲ ಅರ್ಥ ಆಗಲಿ ಇಟ್ಸ್ ಪರ್ಮನೆಂಟ್. Second ray, let me consider a ray incident at point P, pole. Then definitely it will move like this. Where it is formed? Here there is no question of formation of real image. ಇಲ್ಲಿ ಏನಾಗೋದಿಲ್ಲ real image form ಆಗೋದಿಲ್ಲ. There is no question of formation of real image. Only virtual image is formed inside the mirror only. To construct image, what you have to do? You have to just draw it backward. Here, this is the focal length. This is focal length, virtual. What about this? This is reflected ray. We have drawn it backward. This is also reflected ray. Reflected ray. Once again, let me draw some line. See, these two lines meet somewhere here. Then here image is formed. I hope you understand. Here image is formed. Image formed here, which is always diminished. Chikkadagira, diminished. Erect, straight again. Erect one. And of course, virtual. In all positions, ಎಲ್ಲ ಪೊಸಿಷನ್ಗಳಲ್ಲಿ from infinity to say somewhere between P and F, some whatever it may be, P and F, okay, P and F, ಎಲ್ಲ ಪೊಸಿಷನ್ನಲ್ಲಿ ಪಾಸಿಬಲ್ ಎಲ್ಲ ಪೊಸಿಷನ್ನಲ್ಲಿ only diminished, erect, virtual image is formed. In all the cases, we get only virtual image. How? All the images will form between P and F only. Whatever the position, image will be formed between P and F only. This is the case of what? Convex mirror. Convex mirror. To understand this or these positions, different positions of object, once again. Okay. Once again, let me check the battery. That's good battery. Okay. If you understand this position, different positions and image form, let me repeat, very useful in conducting experiments, optics experiments. At the same time, solving problems. Some of the problems where nature of image, all those asked. Right nature of image. One thing I would like to tell you, what whenever object is moved towards the mirror, object and mirror move ಮಾಡಿದಾಗ image will move away from the mirror. Whenever you move object towards the mirror, image will move away from the mirror. This is one question, probably the first problem they have asked in our NCERT textbook. With this basic knowledge, already 43 minutes, anyway, just another 5 to 10 minutes. With this basic knowledge, we have to derive very, very important derivation in second year, chapter number 9. So-called mirror equation. Very important. Concept is called, let me write, very, very important. 5 marks. Name of the concept is mirror equation, or it's also called what? Derive mirror equation in case of concave mirror producing real image concave mirror in case of producing real image. Very important derivation. Okay. First I will draw image. I mean ray diagram. First I will draw ray diagram. ಈಗ ಈ ಹಿಂದೆ ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳಿದ್ನಲ್ವಾ, ಅದು ಇಲ್ಲದೆ ಈ ರೇ ಡಯಾಗ್ರಾಮ್ ಹೋಗಕ್ಕೆ ಹೋದ್ರೆ ತುಂಬಾ ನೆನಪಿಟ್ಕೊಳ್ಬೇಕಾಗುತ್ತೆ, ಗಜಿ ವಿಜಯ ಆಗುತ್ತೆ. ಮಕ್ಕಳು ತುಂಬಾ ರಾಂಗ್ ಮಾಡ್ತಾರೆ ವೈಲ್ ಡ್ರಾಯಿಂಗ್ ದಟ್ ಡಯಾಗ್ರಾಮ್. Now if you know the rays to be considered while drawing a image and nature of object in image in case of concave mirror, it's very easy to remember. Okay, here let me draw that you consider a concave mirror xy, concave mirror xy with principal axis four C. Consider an object placed at certain distance from the concave mirror. Okay. Now, let me consider first ray. Area of light starting from this object incident at M, at radius M. Okay, and which is passing through. Of course, this point will be F. Now you are very much familiar. This point is there. Correct. Then usually I take this point M to avoid any confusion. Okay. This is first ray to be considered. What about second? As I told earlier, this is what there is number. Second ray, we consider it is passing through what? O. This O. Let me draw it once more time. Okay. This is second ray. This is also a moving along what? Principal axis. Now, this will, after reflection, move like this, correct? Here you get some point where image is formed. Image is formed. Okay, no problem. I will draw somewhere here, okay? One second, or you get confused. This is F, no problem. This is second ray passing through P, correct? Okay. Let this be second ray. Then we know this is the angle of incidence theta. This is angle of reflection theta. Here we have point of intersection, correct? To let's take here. For simplicity, to derive this equation, we have to consider one more ray passing through what? Passing through this object incident on. That's what I am thinking. One second. Let me draw it very easily. Let me extend this. Yes. Here. This is point C. This is a position of image. Yes. Beautiful. This is position of image. Here we have to consider three rays. Ray 1, ray 2 and ray 3. I hope you understand. First ray, okay, is passing incident at point M and it is passing through F. With scale it's very easier. Because it's quite no problem. No problem, we can write it. Second way we have to consider a ray incident at P. After reflection, it will pass to same. It will pass to same point. It will pass to same point. Second. Third ray, we have to consider a ray from this object and passing through C. After incident, it will replace its path. These are the three rays in this picture. So very easy to draw if you know the position of C. What is the position of what I mean to say position of image and object? As your object is beyond C, your object is beyond C, automatically you get your image between C and F. And see here, it is inverted anyway. You know this. And size of the image is less as compared to object. Without knowing position of image form and rays to be considered, you have to remember both things. ನಿಮಗೆ ಒಂದು ವೇಳೆ position of image form ಎಲ್ಲಿ ಅಂತ ಗೊತ್ತಿಲ್ಲ ಮತ್ತೆ ಯಾವ ರೇಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಬೇಕು ಅಂತ ಗೊತ್ತಿಲ್ಲ ಆವಾಗ ನೀವು ಏನು ಮಾಡಬೇಕಾಗುತ್ತೆ ಇದೆಲ್ಲ ಪಿಕ್ಚರ್ ನೆನಪಿಟ್ಕೊಂಡಿರುತ್ತೆ ವಿತ್ ಸ್ಕೇಲ್ ಇಟ್ಸ್ ವೆರಿ ಈಸಿ ಸ್ಕೇಲ್ ಇದೆ ಹಾಕಬೇಕು ನಿಮಗೆ ಸ್ಕೇಲ್ ಕಡಿಮೆ ಕಂಡ್ರೆ ಇಟ್ಸ್ ವೆರಿ ಬಿಗ್ ಪಿಕ್ಚರ್ this is a what figure you are supposed to remember you are supposed to remember you are supposed to remember very easy three rays first ray from this object incident on M we know ray number 1 this is second ray probably ray number 3 second ray incident on point P and reflect back. This is third ray passing through C and it will replace its path. All the three rays intersect at a point, meet at a point where image is formed. How to derive this equation? We will continue tomorrow class. It's already 53 minutes in tomorrow's class. But remember, maneli try ಮಾಡಿ figure ನ ಹಾಕಿ ತುಂಬಾ easy. You know the what rays, also what image and object nature alva ಒಂದ್ಸಲ ಎರಡು ಸಲ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ with scale and all those things is very easy you will get very easy ಅದಾಗ್ತಿದೆಯಾ anyway this is very important one okay I'll stop here dear friends ನಾನು ಸ್ಟಾಪ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ ಓಕೆ ನಾಳೆ ಸಂಡೇ ಮತ್ತೆ ಮಂಡೇ ಭೇಟಿಯಾಗೋಣ ರೈಟ್ ಟೇಕ್ ಕೇರ್ ಗುಡ್ ಬೈ